In math, we learn how to take an equation and graph it, but then we learn how to go the other way and look at a graph and produce the equation it came from. In this video, that's what we're going to do. We're going to do the second thing, looking at a graph that's already produced and figuring out the equation it came from. Now, normally students learn how to take the equation and graph it before doing this because it tends to be a little easier and it kind of opens the door to doing this. If you aren't thoroughly familiar with graphing equations, please look at my video entitled Graphing Linear Equations. Before continuing with this video, you can find the URL to that video in the description below. What you see here will make more sense if you already know how to graph an equation. However, if you're pressed for time and your goal isn't a thorough understanding, you might find all you need here to get the job done without the other video. Okay, so let's go ahead and do this. Here's what you need to keep in mind when you're graphing, when you're looking at a graph and you want to figure out the equation it came from. Well, you need to keep in mind the basic template or format of a linear equation. This is a straight line. That's why we call it a linear graph, and it comes from a linear equation. Linear equations don't produce anything that curves. They just produce straight lines. So they're really the most basic kind of equation. Okay, well, every linear equation can be expressed as y equals some number times x plus or minus another number out here. Okay, every single linear equation can be expressed like this. So really, all we need to do is take this basic template and figure out what is m and what is b. So first of all, let's talk about what b is. Well, b is just the y-intercept. Okay, what is the y-intercept? Well, it's just the place that the graph cuts the y-axis. You can see here, in this particular equation, b, get a different color, b is positive 4. So now we already know what b is. So let's talk about what m is. So m is a little bit more complicated, but not too bad. M is going to be a fraction that expresses the ratio of the change in y over the change in x. We call that delta y and delta x. It just means a change in. Another way that you may have heard it expressed is rise over run. And what it is simply looking at a comparison between points. How much did x change from one point to another? You have to be looking at 2 points to do this. And you look at the first point. I like to take the one farthest left and look at it and then think, okay, to get to the next point, how much did x change and how much did y change? And then you're just going to put those distances that it changed in a fraction. So when you're looking at a graph, you need corner points. We don't want, stuff, if we can help it, like that may or may not be exactly halfway through there. I wouldn't necessarily count on that. But I know this is a nice corner point, and this is a nice corner point, and that's all you need is just 2 nice corner points. Sometimes you might have to pick one that's halfway in between, but, just do what you have to do. But it either needs to be a corner point or exactly halfway to be realistic. Okay, so looking at these 2 points here. So I'm at the point 0, 4, the y-intercept in this case. Okay, well, what is this point? Well, this is the point 1, 2. To get from this point to this point, how much did x move and how much did that make y move? Well, so you need to basically look at something like this. Okay, what's the change in x? Well, the change in x was 1. X went 1 in the positive direction. But then when x moved in the positive direction, what did y do? Well, it went 2 in the negative direction. So it basically lost 2 when x gained 1. Well, these two numbers are exactly what we want to make our slope. You're always going to put y movement in the top of the fraction. Don't get that mixed up. And x movement is going to go in the bottom. Okay, well, this is our slope. The only thing that really we want to do is we don't need that 1 on the bottom. We know it's just -2. And there we have it. There is our m. We have a b and we have an m. Remember, this here was m. Okay. Once you have your b and your m, you're done. Just write the equation now. Just take this format, write it just like this, except instead of m, put what you know m is, which is -2. And then next is x. And then next is b. Well, b ended up being +4 in this case. And this is the equation that produced this graph. Let's do another one. So looking at this, I can already see that b is 3. b is +3. Okay, so what is m? So make a fraction. Remember, we're going to do x movement on the bottom, y movement on the top. But first, we need to find a couple of corner points. So that's a nice corner point. And that's a nice corner point. There's a nice corner point. By the way, on this over here, the first one we did, notice that if I look at any of the other nice corner points, the same ratio happens. 1x positive, 2x is negative. 1x positive, 2x negative. 1x positive, 2y is negative. 1 over 2 down, 1 over 2 down. And when you keep doing the slope, it keeps giving you more points that keep you on that line. So with that in mind, well, let's look over here. I can either use these 2 points or these 2 points. So let's use these. Let's look at x movement. Okay, so you need to go the number of x's that will line this point up with this point. And so here, x is going right 2, so that's +2. When x went from -4 to -2, what did y do? Did it lose? Did it gain? Did it stay the same? Well, when we went from -4 to -2 of x, y went from -3 to 0. That was a change upward of 3. That's +3. And so in my slope, I'm going to put the change in y, which was +3, over the change in x, and this is my slope. Now I have an m and a b, so I'm all set to write my equation. So I'm going to write y equals, and now again I'm doing this, y equals mx plus b, but instead of m, I'm going to write 3/2, and then my x, and then b is +3, and we are done. This is the equation that produced this graph. Notice I could have done this point to this point, and I would have still had the same thing. A change of +2x produced a change of +3y. Okay, on this next one, so I need to find some nice corner points. So we can use that one and that one. Any of those will work. So going from one to the other will work. So I think I'll use this one. It looks like if x goes 1 positive, that means 1 to the right, then y goes up 2. So 1 positive, 2 positive, so m is going to equal, so my y movement is 2 up, and my x movement is 1 over, 1 positive. So we could just call that 2. So this 2 over 1 obviously reduces to 2. So I have my m. What is b? Well, b is the y-intercept. So this graph is getting cut at a y value of 2. So b equals 2. And there we go. So my equation is going to be y equals 2x plus 2. And we are done. Next, let's do this one. So it looks like we have a corner point here. And here. And that's enough. You can find more if you want. Looks like that's a corner point there. Okay, so I'm going to have to do an x movement of 5, and y is going to lose 4. Y went down 4, so that's negative. But going from -5 to 0 of x, we gained 5. So that was 5 positive. So m is going to be, remember, always put the x on the bottom. So for a positive gain in x, y dropped 4 to get to the next corner point. And so our slope is, and normally if you have a negative, you just set it on the side. It's the same thing. So this is going to be my m. What is b? Well, b is 0. Okay, the y-intercept here is 0. The graph is cutting the y-axis at 0. And so my equation is going to be y equals -4/5 x plus 0. But then obviously we don't need that plus 0. So you can just shorten it to 4/5 x. And there is our equation. Y equals -4/5 x. Okay, on this next one, looks like we have a corner point here, and then we don't have another one till, looks like right there. Okay, so that means we're going to have to go this many x's to line up with that one, and then that's going to show how many y's that we, in this case, it's going to gain. So how many is the x movement? So 1, 2, 3, 4, 5, 6. So x had a gain of 6. It went positive 6. What did that do to y? Well, y rose from -1 up to 4. So it went up 1, 2, 3, 4, 5. So it went 5 up. So both the changes are positive. So x movement was 6, and it produced a change of 5 in y. Here's my m. What is the y-intercept? Well, here, that's exactly halfway in between. So this is my y-intercept. It's where y is getting cut by the graph. And so b is going to equal 1.5, or let's just call it 3/2. And so my equation is going to be y equals 5/6 x positive 3/2, and this is our answer. Okay, for this last one, so let's think about what is b. Well, b is -2. This is where the y-axis is getting cut. Okay, now we need an m. So really any point here works. These are all, we can put corner points anywhere, wherever you want. It doesn't matter in this case. I think I'm just going to take from here to here. Okay, so from here to here is a change of 3 x's. Okay, how much did y change? Well, y went from -2 to -2. That means there was 0 change. So for a gain of 3, and we could have done it with anything, we could have done 50 x's, and y still would not have changed at all. So this bottom number is kind of irrelevant in this case. Well, 0 over anything is just 0. 0 thirds means no thirds. So m is 0. So we have an m, We have a b. Let's write our equation. Y equals 0x, and b is -2. But 0x, 0 times anything is just 0, which means there's actually nothing here. And so we can condense our equation to simply y equals -2. So notice when you have a positive slope, you're rising from left to right. Remember, we read always from left to right. So if your function is rising from left to right, that is a positive slope. If it is falling from left to right, that's a negative slope. So positive slope, falling from left to right, that's a negative slope. If you have a slope that is not rising or falling, well, that is a zero slope. So it kind of makes sense, positive, 0, negative, okay, positive, 0, negative. Okay, what if it's going straight up? That is undefined. That's something that would be good to remember. Undefined. So if you had a line, I don't really have room here, but I'm just going to, let me get a different color. Okay, so now I'm done with this problem, but now I'm doing something else on this graph. If you had a line like this, that is simply going to be x equals -1. Okay, again, don't get this mixed up with the problem we were looking at originally here. It has nothing to do with that anymore. I'm doing another problem, just showing you real quickly here. So x equals -1, these are like kind of the weirdest ones of all. There's not even any y's in it, and there's not even a slope. This vertical line does not have a slope. The slope is undefined. It means it doesn't exist. It doesn't compute. It's not usable. There's no way to figure out a slope for this. So, again, positive, negative, 0, or undefined. Those are your 4 types of slopes. Hope this helps.